Hi friends, in this video I would like to share a problem on previous class, that is sampling distribution. If you missed that video, please check it in description box. Now the problem is a random sample of size 2 is drawn from the population S is equals to 3, 4 and 5. Now we have to find population mean, population standard deviation, mean of sampling distribution of means, that is also called as MSDM, and standard deviation of sampling distribution of means, which is known as SDHDM. SDHDM stands for standard deviation of sampling distribution of means. Now I have to go to solve this problem. First of all, what is given? Here the population is given that S is equals to 3, 4 and 5. This is given population. Also each random sample is of size 2, that is n is equals to 2. Here the number of elements in the population are 3. So capital N becomes 3. This is the given information. First of all, we have to find out what is population mean. Population mean. Generally, population mean can be denoted by mu. Which we have to find. We know that mean of the population can be defined as mu is equals to sigma x by n. That is, here x is the each element of the sample, that is x is equals to 3 and x is equals to 4 and x is equals to 5. That means we have to take the addition of the sum of those sample space elements. This sample space is also called as a population for this case. So mean becomes 3 plus 4 plus 5 by total number of elements in the population is 3. By adding this we get 12 by 3. That is nothing but 4. So mean of the population becomes 4. This is the first answer. Now friends, now I have to find another problem, that is population standard deviation. Sometimes it is also called as standard deviation of the population, which can be represented by sigma. That is population standard deviation. Friends, we already know population standard deviation or standard deviation is the positive square root of variance. We know that variance. What is the formula for variance? We know that variance, which can be represented by sigma square, is equals to sigma x minus mu by n x minus mu whole square, there is a whole square, x minus mu whole square by n. Here mu is the mean as we calculated in the above, that is the value of mean is 4, and x is the each element of the sample space or population. So we have sigma square is equals to, first of all we are substituting 3 minus, that is 4 whole square. Sigma indicates sum of the terms. 4 minus 4 whole square plus 5 minus 4 whole square by 3. So we have so we get the value is equals to 3 minus 4 whole square, means there is a minus 1 whole square, plus 4 minus 4 becomes 0 whole square, plus 5 minus 4 becomes 1 whole square by 3. That is sigma square is equals to 1 minus 1 whole square is nothing but 1 plus 0 plus 1 by 3, nothing but 2 by 3. Then standard deviation sigma is equals to positive square root of variance, nothing but under root of 2 by 3. This is the value. By simplification we got 0.8164. This is required about standard deviation of the population. Friends, now I would like to find mean of sampling distribution of means. Mean of sampling distribution of means. Of course, this is the short form as denoted with MSDM. Of course, which can be represented by mu suffix x bar. Mu x bar denotes, mu x bar is the notation for mean of sampling distribution of means. First of all, we have to find what is the sampling distribution for the given problem. Of course, we already discussed in the last class what is a sampling distribution, in the sense the process of selection of sample from any population. The process of selection of a sample from the given population is called sampling distribution. Of course, this sampling distribution can be done in two ways. One is sampling distribution of for a finite population, and another one is sampling distribution for an infinite population. Sampling distribution for a finite population is also called as sampling with replacement, and sampling distribution without replacement for an infinite population. Friends, as he mentioned, of course, when he mentioned about sampling distribution of finite population or sampling distribution of infinite population, as is usually given in the problem. Of course, when he doesn't given anything, you have to find, better to find both cases. So first of all, I would like to find what is sampling distribution. Sampling distribution can be find for first in the case of infinite population. That is, I am finding both cases, in which first one is for an infinite population. For an infinite population, which is also called as sampling with replacement. This is also known as sampling with replacement. Friends, whenever you are finding about an infinite population, that is also called as sampling with replacement. We can use the formula for number of samples is nothing but n power n. Here the number of samples can be calculated from n power n, nothing but 3 power 2. So there exist 9 samples, of each sample is 2. 9 are the number of samples. Number of samples in this case, which are 3, 3. Why? Because it is a sampling with replacement case. That means 3 is replaced again 3, and 3, 4 and 3, 5. Similarly 4, 3, 4, 4, 4, 5 and 5, 3, 5, 4, 5, 5. These are the 9 samples of each sample size 2. Now, first of all, we have to compute all samples means. That is called as sampling distribution of means. That means you can calculate each sample mean. How you calculate? Suppose I am taking the first sample, that is 3 by 3 and 3. Its mean becomes means of the above samples are 3 plus 3 by 2 becomes, friends, you can see here, I am taking a rough note. First sample from 3 comma 3 we are getting 3 plus 3 by 2 nothing but, again we are getting 6 by 2 is nothing but 3. So that is, this samples mean is 3 and this samples mean is 3 plus 4 by 2 nothing but 7 by 2 nothing but 3.5, and last one 3 and 5, the sum of 3 and 5 is 3 plus 5 is equals to 8, and its mean is 3 plus 5 by 2 is nothing but 8 by 2 nothing but 4. So we get the samples means are 3 and 3.5 and 4 in the first line, whereas in the second line again we are getting 4 plus 3 by 2 in the sense 3.5, 4 and 4, sum of the 4 and 4 is nothing but 8 by 2 nothing but 4, and 4 plus 5 by 2 is nothing but 4.5, 9 by 2 becomes 4.5, and in the last row we are having 5 plus 3 by 2 is nothing but 8 by 2, 4, friends, we are discussing about the last row which are having 5 and 3, sum of 5 and 3 becomes sum of 5 and 3 becomes 8, 8 by 2 is nothing but 4, and 5 plus 4 is nothing but 9, 9 by 2 is becomes 4.5, and 5 comma 5, sum of the 5 and 5 becomes 10 by 2 becomes 5. These are the means of each sample. Now I am finding sampling distribution as I am taking within a table that is, these are the x values, and I am taking these are the frequency. Of course this is sample mean, x bar, these are frequency. Here I am taking 3, 3.5, 4, 4.5 and 5. 3, these are the sample values, sampling mean values, 3, 3.5, 4, 4.5 and 5. Friends, here observe that there is only one 3, that means this is repeated only one time, that is frequency of 3 is 1. Friends, here the sample mean 3 comes only one time, that's why its frequency is 1. 3.5 comes 2 times. See here, this one is 3.5, another one is 3.5. So there are two 3.5s are there. So you can take 3.5 frequency are nothing but 2. Again 4 is also, how many times are there? Here there is a 1 4, second 4, third 4. That means 4 occurs or 4 comes 3 times. That's why the frequency of 4 is 3. Again 4.5 comes 2 times. That's why this is the frequency of 4.5 is 2. And lastly we are having only 1 5. That means frequency of 5 becomes 1. So friends, by using this sampling distribution we can find out MHDM. MHDM also known as mean of sampling distribution of means, which can be represented by mu x bar, which can be represented by mu x bar. That is equals to, there is a formula for this, that is nothing but sigma x bar into f, sigma x bar into f by sigma f. That is, see here, x bar value is 1 3, and frequency how many times it occurs, 3 comes only one time, plus sigma indicates sum of the values, 3.5 is the another frequency that comes 2 times, and the third one is the sample mean is of 4, which comes 3 times, and one more sample event, that is 4.5, which comes 2 times, and lastly we are getting only one sample mean, that is 5, which comes only once. That's why I am taking only one, and by I am taking the sum of the frequencies as, friends, you can observe that what are the f values. F values are 1 2 3 and 2 and 1. That means 1 plus 2 becomes 3, 3 plus 3 becomes 6, 6 plus 2 becomes 8, 8 plus 1 becomes 9. So the sum of the frequency values becomes 9. That means mu x bar is equals to, by adding these values, how much you got, 3 plus 7 plus 12 plus 4.2 into 2 means 9 plus 5, we got 36. 36 by 9 is equals to 4. 9 1 9 4. So it is clear that mu x bar is equals to 4. As you observed that the value of mu and mu x bar are evidently equal. So this is about MHDM. Friends, we are entering into last part of the problem, that is, it is enough to find sampling distribution of standard deviations. Friends, we are going to conclude this problem by finding standard deviation of sampling distribution of means, that can be represented with SDM, which stands for standard deviation of sampling distribution of means, which can be represented by sigma x bar, sigma x bar. As we discussed in the above case, how can you find the standard deviation? The standard deviation can be found by using variance. Why? Because standard deviation of any distribution is nothing but positive square root of variance. We know that variance equals to, what is the formula for variance? We know that variance is equals to sigma x bar square is equals to sigma fi into x bar minus x whole square by sigma fi. That is sigma x bar whole square is equals to, first of all, from the sampling distribution table we have f value is 1 times of 4 minus 3. Friends, you can take this value is also this type. Why? Because sigma fi into x minus x bar. Of course, while you are taking square, there is no effect on by interchanging x and x bar. So you can substitute the x value. First, what is the first value of x? 3. 3 minus 4 whole square plus how many times of the second f value is 2 into the corresponding sampling mean is 3.5 minus 4 whole square plus third f value is 3 and corresponding sampling mean is 4. 4 minus 4 whole square and 2 times of 4.5 whole minus 4 whole square plus 1 times of 5 minus 4 whole square. This is about the value of sigma square by sigma fi. Sigma fi is nothing but sum of the frequencies. How much? That is 9. So finally what we got? Therefore sigma x bar square is equals to 1 by 3. 1 by 3. Now it is easy to calculate the variance of the problem, that is we are getting variance of the problem, that is 1 by 3. As I said before, standard deviation is nothing but sigma x bar. This is the standard deviation of sampling distribution of means, that is sigma x bar is equal to positive square root of variance, nothing but one by root 3, which is equals to 0.5773, which shows sigma x bar is equals to sigma by root n. Whatever you got, the value of sigma is 0.8164 by the sample size is root 2, that is 2, becomes 0.5773. This is the problem for finding population mean, population standard deviation, as well as mean of sampling distribution of means, standard deviation of sampling distribution of means for an infinite population, that is sampling can be done with replacement. Friends, in the next class we would like to share some more problems on this sampling distribution. Thank you for watching my video.